Welcome to It's a Controls Problem, where we do precision guesswork based upon unreliable data given to us by those of questionable knowledge. I'm your host, Charles Johnson. Hello and welcome, everyone. Welcome to another episode of It's a Controls Problem. I am your host, Charles Johnson, and with me in the studio across, the country is the one and only Matthew Vanberg. Matthew, how are you feeling tonight?
I'm feeling well.
Let's go ahead and get into our discussion. We had an episode where we left off. Where we were talking about what to expect when you're connecting controls. That is, I kind of feel like that's more of the what was that? Beverly Hillbillies, like oil. That is black gold, Texas tea. Anyway, never mind. Not really important. This is where Matthew would probably insert the laughing. The laughing sound from the audience there, if there were.
I do
an
have
audience.
a laugh track. I do.
That's it, laugh track. Words are hard. I couldn't think of laugh track, but yes. And so to kind of summarize first, and then continue into that, kind of expounding on some things. The first thing I wanted to talk about was how to. What we needed to learn as far as the controls industry. And, we talked about, having to learn multiple trades. So, we want to talk about, the Honeywell Gray Book. So the building automation guide for controls, and BAS input and output by Francisco Valentine. And there are some others that you could get. You could get Phil Zito's book as well. But we talked about, the importance of, being able to wear multiple hats and what controls embodies as an industry. And then we talked about as far as roles from an installer standpoint and from a technician standpoint. And then we even expounded on point to point and programming checkout, and then a little bit of that. And then we talked about some of the project manager and salesman roles. We then we discussed about having safety equipment and PPE, and what it was like to be a technician, like on the first day of the job, including like doing like a walkthrough, reading documentation and sending reports to a project manager, etc. And then at the end, we talked about project management. So, we discussed a wide array of things, but I think where I kind of want to go back to is more of a judgment call. So if you're a technician and you're on site and you have to go up a very high ladder, but there really isn't, let's say there isn't a tie off, or let's say you have to, let's say that you were supposed to have a scissor lift and there's no scissor lift on site, but the project manager wants you to install like a VAV controller because the installer forgot to do one, or you wanted to just check out one in a high area. There are a lot of times where, unfortunately, you're going to have technicians that are just going to climb up that ladder and just get it done to get it done. But I've done that before, and I fell off that ladder, and I had significant injuries to me. And so, one thing that you may want to do, especially stuff like that, is push back on the project manager, and maybe even getting someone higher up involved to say, hey, look, there's no tie off here, especially since a lot of construction sites, they care about OSHA. That's the Occupational Safety and Hazard Administration, or Safety and Health Administration. I think it's Safety and Health Administration. Point being that OSHA has a set of regulations that you need to maintain, and one of them is actually tying off. So it's kind of strange. Like I believe it's either 3 feet or 6 feet. I forget which one, but it's one of the two. Like for every 3 feet, or if you go above 3 feet, you need to tie off. But the hilarious part is you have to climb up that way to tie off regardless. So like the initial climb could be potentially unsafe, but then after that you should be okay. But what if there isn't a tie off? Well, for me, having those kinds of experiences, and with accidents like that and having serious injuries, your safety matters. You may have a family that you need to go home to, and you are you're the main provider. Workers' comp doesn't give you that much, so since your health and safety matter, please make sure that you make someone aware. And if you're getting a lot of pushback on that, I kind of implore you to, talk it out with someone who can reason with the person that's telling you, like, hey, you know what? I know you're asking to do something really unsafe, but I don't think that that's right. Let's do the right thing and, get the scissor lift, or, have a scaffolding or something like that. If you know that you're working in something that, a very let me see, I'm trying to think of another scenario that would be really good. That was the first one that was off the top of my head, but I mean, there are times where you're in a tight fit, or maybe you're in a you're potentially in something where hazardous material could happen. Make sure that you have your safety mask, or make sure that hazardous material has been removed ahead of time. Another one that's unsafe. Working somewhere that's live, and we'll get more into electrical at that point. But working in live panels is a no-no. We do it all the time, and I'm not saying that that's right. But make sure that when you're working in something, especially if you're an installer, or if you're a technician, because technicians have to wire up panels, or rather rewire panels. Make sure that like that 120 is off for sure. Or if you need to actually install a current switch on like a VFD, make sure that we have the lockout tagout necessary to make sure that we don't hurt ourselves. I've been hit by 208, been hit by 277. I've not been hit by 480. But I know a friend that was hit by 480, and let me tell you, 480 will grab you. It can cause some serious damage, though. Obviously, from an electrical standpoint, it's the amperage that kills you, not necessarily the voltage. Doesn't mean it can't injure you any less. So make sure that when you have safety concerns, bring them up. And if necessary, talk to the safety inspector, see if they have any additional equipment on site to help you. If not, push back on your project manager to make sure that they get you the appropriate equipment to do your job. Sometimes project manager, they want to try to save costs, right? That is one of the important roles of the project manager, is to make sure the job comes in under cost. But that doesn't mean that you should compromise safety to save a few dollars, because at that point you could be paying out millions of dollars instead. So, I implore people to use better judgment when it comes to getting those jobs done. Matthew, like with jobs, normally there's a job schedule that is passed down. Well, sometimes that schedule can increase, like, hey, we need to pick up the pace here. And so sometimes, because things get pushed ahead or things get reworked, some people then, or it can cause a rush on your part. And while I usually say, poor planning on your part doesn't mean, and it should indicate a rush on our part, it's almost rarely the case. You are pushed to get stuff done, and people overlook safety when it comes to that. And so really make sure that you understand the consequences if you decide to do something unsafe. Speaking of, electricity or electrical stuff, one book I didn't tell you about when we were talking about the Gray book and Francisco's book BAS Inputs and Outputs. One book that will cost you about $20 if it's a paperback, or I think it's like $6 or $7. It's on your phone. It's actually called Uglies. You heard me correctly, Ugly's Electrical Reference. And if you get the app, it actually has like a bulldog's face on it. But Ugly's Electrical Reference can teach you anything about the electrical principles. It'll teach you about circuits, 480 motor circuits. It has anything that you can need to learn about NEC, the National Electrical Code. It can take you it can teach you anything like that. And once you start learning that stuff there, when it comes to troubleshooting or understanding electrical schematics, an issue that you might encounter would be a relay. Let's say there's a short, and so a relay is supposed to have a coil and a contact, and the coil is kind of the electromagnetic side, and the coil is actually a coil because it generates resistance. So it works as a magnet to pull in the contact, whether it's from a normally closed position to a normally open position. Well, you have a common of the relay that is common to both the normally open and normally closed contact. Typically, that's where you put your power, like your 24 volts VAC or 120 or 277. It doesn't matter what that voltage is. The point is that that's where the voltage comes in, and then on the normally open contact, you can have, you'll have that go to somewhere applying power, but then there needs to be a common to go to the common side of your electrical circuit. Otherwise, you're gonna create a short circuit there. And so when you can create a short, you can actually pop relays. You can pop transformers, breakers, etc. And so, when you're kind of reading those schematics, make sure that you can understand, what you're looking at specifically. And I believe I said this the last time, but I do want to reinforce it here, is have a highlighter and your control drawing. And if you don't have a control drawing, draw it out the way that you think it should work. And that way you can actually look at the piece of paper and be like, well, all right, I've got the hot, I've got the common, they're going there, that's going across the relay. And now I have the 24 volts going to the common of that part of the relay. And now the normally open contact's going to the start of the fan, and then the common of the fan terminals, that's going to the 24 volt common. Okay, great. Now let's go ahead and start highlighting those wires that you touch to make sure that it's wired correctly. And there are times where once I highlight it and I have verified that is that piece of wire, I don't have to touch it again. And so I had a scenario where I was mentoring two installers, and they were new to controls. They moved on from the company that I was mentoring them in, but they started to get some solid foundations, but they were kind of wanting to just slam things in and trying to work as quickly as possible. In the contracting world, you have good, fast, and cheap, and you can only choose two of the three. But just because you rush something doesn't mean you're good at it. And so some people think that equates to efficiency, and it's not. I'd rather you spend an hour wiring something and it's 100% correct than having you spend 10 minutes wiring something and going back 2 or 3 times to rewire it. Because guess what? You're going to spend more time rewiring that than than it would have taken for the initial time that you had if you had invested that time in wiring the piece of equipment correctly. So especially when you're looking at a control drawing, you may find a panel diagram, and sometimes you may use terminal strips, and those terminal strips can go from your inputs and outputs to something, and then the other side of those terminal strips go to the actual end devices. And wiring the wire from the device to the input or output directly, it creates a cleaner panel. But sometimes because of that, especially with like relay outputs where you have to jump 24 volts. Well, sometimes terminals get skipped, or the wrong terminal gets a 24 volt jumper. So it's really important from that side to draw it out or look at the control drawing and find out where it actually should be, and then test it from the terminal side. And then once you test it from the terminal side, then we can always apply from the inside out or outside in, but start with one direction and then move either forward or backwards. So if you start from the end device, make sure that those wires are good before moving to the panel, and vice versa. So relays get wired wrong all the time, as far as creating a dead short. So make sure that you don't create those dead shorts by following your system that you put into place for maintaining in the integrity of your wire. Another wiring issue would come to if you're missing, sometimes someone misses a common somewhere, or sensors get wired backwards. So like, how do you wire a sensor backwards? It's two wires. Yes. What I mean is, like, you may have a supply and a return sensor, and the supply is supposed to be on input 3 and the return is supposed to be on input 4. But when you look at it, input 4 is reading 55 degrees, and the and input 3 is reading 75. And the chill water valve's open, and maybe you've opened up the cooling coil side of an air handler, and you can feel the water, the cold air blowing. So at that point that the valve is open, we're supplying cold air. The sensors are just backwards from a panel perspective. I've seen VFDs where you're not from a safety circuit, you're not supplying the 24 volts that's needed. That's very common, where the 24 volts typically is 24 volts DC that's required for like a VFD safety circuit to make sure that you can enable it or disable it appropriately. I've found that some people just don't bring the power to it. It's just a matter of finding the terminal blocks that you need to wire to and verifying those terminals. One annoying thing that I see on control drawings is field verify. And fun fact, Matthew, for every 1 hour that's in the office in engineering, it takes roughly 8 hours to figure out in the field. So some engineers don't have enough time to do their design, and so they just say field verify everything. And now it's up to the technician to figure it out, potentially even for the installer, because typically installers are just going to read the control schematic and wire it the way the control schematic has it laid out. They're not necessarily the actual troubleshooters. It's really the technician that can be. Now you'll have some rock star installers that have done enough controls jobs where they can offer insight, like, hey, Mr. Design Engineer, that's wrong there. You gotta do it this way. And there are some that I actually see on LinkedIn, that give that have the installation practice and knowledge. And so, they'll give the advice as well. But most of the time when an installer is given a set of control drawings, they're running the wires the way that they're, and it's up for the technician to make sure that things are wired appropriately. But when things need to be field verified, well, they don't know how to field verify that. Only you then, only you are able to actually do that. I was about to say only you can prevent forest fires like Smokey the Bear. But yeah, it's really at that point the technician to kind of make sure everything's coordinated that way. Does that make sense to you?
Yeah, you weren't too far off, right? Because fires can occur in this circumstance when we're talking about electricity.
Oh yeah, like VFD. That's a great one to do. I remember. So one thing to know that because of the DC voltage in a VFD, when you power it down, there still could potentially be voltage on the VFD itself from the or on the DC side, and so you really want to wait about 5 minutes or so before you actually get into the VFD and start playing around with some of the wires that are in there. But I've had some people that just like turn off the VFD and immediately just want to put their hands in there. I'm like, what are you doing? And there was a guy who was working on a VFD live, and someone was actually hovering over them. And before I could get over to the other guy to kind of move him away, he kind of tripped, and the guy got into the VFD and really got some bad electrical burns because of it. Now, granted, it shouldn't have been live, but sometimes people will turn off the VFD at the disconnect at the VFD, and then they'll just take a pair of channel locks and go ahead and turn on the VFD again and kind of doing some stuff, and that's not really recommended, but people do a lot of live stuff all the time, which is not really recommended. But sometimes people do what they do to get the job done, and again, that kind of goes to safety. Just because you want to get it done doesn't mean you're safe about it, and to me, safety is more important than that. Um, Go ahead.
That makes me think about talking about the DC and different types of currents, and maybe bring up how important it is to not assume the equipment you're working in with or installing is uses a certain type, and that you should double check that, because I've heard some stories around this scenario, like our controls at Linkspring, the Genesis Edge line is not power over Ethernet, and people have attempted to power it over Ethernet, and they fry controllers.
Yeah, so things like that. That's actually a good point there. And I'll touch on that in a moment. But what we're thinking about is, let's say you're supposed to have 24 volts somewhere, and let's say it's supposed to be 24 volts DC. Well, or 24, we'll say 24 volts AC. Let's say we're coming off of a transformer, which still could be DC, but not for this purpose. You used to see a lot of people who would not use like a PSB 100A that kind of has like a little fuse in there for like to turn off power with like a power strip or anything like that. What a lot of people do is they'll actually bring in just the 120 as is. Take that to a 24 volt transformer, but also on that 120 side, they'll go to like a terminal like 1 and 2, and that's going to be your hot and your neutral. And some of that goes, part of that 120 actually goes to a like an outlet that they actually create for like where a technician could plug in and where they can actually turn off that outlet there. I've seen where people accidentally like take that 120 and put it on the terminals that the 24 volts should be in, and vice versa. And that happened to me. It was Anne Arundel Community College. Man, this was like, I don't know, 2007, and it literally was just controlling a single exhaust fan. And I didn't actually verify what the terminals were doing. And as soon as I put my screw to a terminal, I melted the terminal. And I saw some sparks, and I was like, oh yeah, I need to put my meter there. Wait, why is that 120 when that should have been 24 volts? And I realized that the job electrician actually got the terminals backwards. So, one thing that could be important is use your electrical meter. And in addition, there's you can have another tool, a tester that will actually, I believe they call it a sniffer. I think that's what it's called these days, but you can actually just kind of put it on somewhere. And if it's live power, then it'll actually beep. So that that'll actually work to see whether or not you actually have power somewhere. But if but put your meter. If your terminal is supposed to say 24 volts AC, make sure you have 24 volts AC. Make sure you don't have 120, and vice versa. If it's 120, make sure you don't have that. Or maybe you're supposed to have DC power instead of AC power. Make sure that you test for DC power that way. When you talked about the PoE, since our and normally bringing up LinkSpring here because it's actually a good scenario. Obviously, LinkSpring, if you're not familiar with it, that's actually the company Matthew and I work for. But we stay as brand agnostic as possible. But we OEM Niagara controllers. And so we have 2 Ethernet ports on each of our controllers. And, a lot of people will take it to a switch. Well, sometimes those switches are PoE, which stands for Power over Ethernet. And PoE switches can have, they can output 24 volts DC or even 48 volts, depending upon the type of switch that you have. For example, like in my house here, I have an Edge Tough switch from Ubiquiti. And it can output both either 24 volts or 48 volts based upon what access point I'm using. But if you take that and put it to an Ethernet port on a Niagara controller, and it actually is set up for power over Ethernet and not just a regular output, well, you will fry the controller, and that's why we actually have a label now. For power, that, hey, these aren't power over Ethernet, so do not apply power there. Now there are PoE switches that actually can detect whether or not a port is power over Ethernet, and it'll actually send a little bit of voltage through. It shouldn't be enough to fry the controller, but just to test whether or not it's PoE compatible. And if it is, and then it'll actually inject the full power to the device. And if it isn't, it won't. But I still dissuade people from using that type. Make sure that for any Niagara controller, even a Jace, make sure that you don't have power over Ethernet there. But speaking of which, that does bring us up to another of types of controllers that use 24 volts AC or DC, and that's when dealing with half wave versus full wave rectified devices. And so the difference between what we call a half wave and a full wave actually has to deal with the signals there, and it's whether or not it actually takes the full wave of the AC, so both the positive and the negative, or whether or not it takes either the positive or the negative, but not both. And so with a half wave rectified device, it only uses one half of that, and the full wave allows both. Well, our 34 series of controllers, whether it's the 534, 434, or a new one that's coming out soon, those are full wave devices, and so it uses the full 24 volt signal, both the positive and negative side. And our 14 series of controllers use only our half wave devices. Other things that are full wave devices, like RIB functional devices. So if you're using any of their relays for integration, such as the BACnet or Modbus, and even the LAN one, if you still had one around. I don't think they make the LAN one anymore, but regardless, those are also full wave devices. And so you need to make sure that if you are using full wave devices and some other devices that may not necessarily be full wave, one, if you're using 24 volts AC, the power has to be floating. You can't have a ground on there. Otherwise, use 24 volt DC. Now, that's why we recommend that you use 24 volts DC, but it's not a 100% requirement to power up our controllers. If you are going to use AC, make sure that it's floating. But most people now go into DC, unless like you're in retrofit situation, which we'll talk about retrofits more later on, but I think it's kind of important to put this here. In a lot of retrofit applications, what happens is that you may keep the sensors in place. Now that could depend upon the product. Like for example, Honeywell, you use a lot of 20K sensors, and if your controller can't accept 20K thermistors, then you're pretty much replacing those sensors that are 20K into like 10K type 2 or type 3 or nickel or platinum or whatever. But what you'll find is that a lot of people are like, well, I know controls. I've been installing controls for 30 years, herp a derp, and then they'll rip out that controller and put ours in, and then they turn on the power. And as you know, any DDC controller has magic smoke. And when you let the smoke out of this controller, well, the smoke does not. You can't put the smoke back in. And while smoke is bad for humans, it is good for controllers. So once it's out, you can't put it back in. You need to replace the controller. So it's really important to know whether or not you have a true 24 volt that's floating versus grounded. Because what will happen is when you ground 24 volts AC, you now actually have a positive side and a negative side. Otherwise, if you leave it floating, it doesn't matter. You have 24 volts. You don't have a positive and negative that way. That's why you'll see like a lot of terminals, Matthew. They'll actually have either they'll have a plus and then a plus side and a minus side, or they're both going to be a wave, right? So the wave actually means it's floating 24 volts AC, but the plus and minus typically, represents either A, you've grounded the controller, you've grounded the 24 volts to have a true plus side or negative side, or that's your 24 volt DC. Does that make sense?
Makes sense to me.
Okay. Good. Now some people may say, well, we can do this with a Jace. Well, a Jace actually is a full wave device, but it's actually isolated. So that part actually doesn't matter. I don't know if there are any other electrical schematics that I want to talk about like that. That there are common wiring issues. Like normally there are issues with relays, or maybe maybe you don't have a ground reference for like your actuators, so off of your analog outputs. And if you don't have that ground reference, the signal doesn't actually get to the device appropriately. So so you actually may not be able to stroke your valves. So you need to make sure that you check that as well. Like if you're using multiple transformers, then you make sure that all the grounds are tied together to make sure they have the same reference. I think that's kind of it for that side. If I think of some more, maybe what we'll do is we'll put like a LinkedIn article out to add some additional things, or if people are listening and people are giving feedback. So if there are more things they want to hear, we'll certainly talk about them. You know what? Actually, I tell you what, we'll talk about programming next, because I think programming checkout, either some companies have the programmer actually do it, or the programmer is doing the other. Programmer is just too busy. They're doing something else, and the technician is actually doing that programming checkout. So the technician will take a program that a programmer has, and they're going to dump it into a controller. Now, they're going to actually be doing the checkout. They're actually going to take the sequence. Hopefully, what they're going to do is they're going to take the sequence. Hey, this unit shall be started and stopped or indexed to occupied or unoccupied mode based upon a building schedule. Okay, great. Well, let's go find that building schedule, and let's go ahead and set it to unoccupied, and let's see the unit turn off. Oh, wait, the unit didn't turn off? Okay, well, before, it could be a programming issue, but maybe before we check the programming issue, let's make sure, that the fan isn't in hand at the disconnect. Okay, well, that's correct, and there's no HOA on the output either. So, okay, fantastic. We know that side's good. And now let's go ahead and we dive a little deeper into the program. Oh, well, he just didn't link the occupied command to our fan. Okay, well, how long is that going to take? Oh, it just takes a click. Great. Go ahead and get it done. But let's say then you get into, let's say you have a VAV air handler, and this VAV air handler has an outside air damper, a return air damper. We're not going to say exhaust, but let's just say outside and return, and let's say we have an economizer sequence. So for those of you who are not really familiar, economizer says, hey, when we are using based upon either a straight outside air, so just and what we call a dry bulb temperature, or a wet bulb, which is a combination of outside air and humidity, or maybe we have, or maybe we're doing enthalpy, an enthalpy calculation of BTUs per pound. And so, if you're doing enthalpy, you're going to compare the outside air and return air enthalpy. And if the outside air enthalpy is less than the return air enthalpy, you're going to go into economizer up until a certain OA temperature, obviously. But depending upon whether you're doing dry bulb or wet bulb or enthalpy comparison, or a combination of all three, doesn't matter. Usually what will happen is there'll be something in the sequence of operations that will say, when we are at 100% cooling on the outside air damper, if we cannot maintain the supply air temperature or mixed air temperature, depending upon which one. Some people will maintain supply, some people maintain mixed air, and there are times in which you'll want to do one or the other. But if you are maintaining supply, well, then guess what? We're going to open up the chill water valve to start cooling, because maybe it's enough to where the chiller can come on, but we can still get some stuff from the unit. We're not warm enough to get out of true economizer, but we're not cold enough to disable the chiller. And so then you may have the chill water valve start opening. And that actually comes from the old pneumatic control, where you take like one signal and then you're controlling the the hot water valve, the damper, and the chill water valve off the same signal. But anyway, there are times where you may need more cooling, and that is a very common sequence. Well, maybe your programming skills aren't that impressive. And realistically, let's say you take a look at it and it's going to take you, oh, they don't have any of that there. Well, that could take, I don't know, an hour and a half, 2 hours of programming time. Well, at that point, as the technician, you probably have better things to do. And if you have a programming department, get the programmer involved and say, hey, look, I tested out this part of the sequence operation. It's not working. And I see that we might have something here, but I'm not too sure. Can you check it out and fix it? I'm a firm believer of getting the person that is responsible for the error to correct that error. Why? Because they need to learn that they have those errors. If you continue to fix something without even letting the person know that they're doing something wrong, then you're culpable of allowing them to continue to have those bad habits that they're forming. Like another one would be, let's say you want to do lead lag off of a differential pressure for a chill water system. There are a couple ways to do that programming, but that may not be your strong suit. You're probably a technician because you can massage a little bit of the code, but you're really good at doing the point to point, and you like getting your hands dirty. And again, some HVAC companies or controls companies, they will have a very lean crew. So you're the technician, you're the programmer, you're the installer, and if that's the case, then this doesn't apply to you. But if you have departments where you have technicians, you have programmers, and you have engineers and stuff like that, get the programmer to do their job, because you're going to help them become a better programmer by making sure that they correct their mistakes. And from a programmer's perspective, hey guys, you may want to make sure that you do some kind of debugging or troubleshooting before you send your code out to the technician. There is nothing more infuriating than sending out a piece of code that you did not test, and that if you had tested it, you would see that it works. And I've heard the old adage, well, it worked before. It worked when I sent it off, and there is no way that it could have, based upon how you see it programmed. So when it comes to that, make sure that you note it in your notes to the project manager, and if necessary, get the project manager to talk to the programmer. Even though you should have direct access to the programmer, the project manager probably still needs to know if if you're charging, or if something is taking you a little longer to do. Why? Like if it's a one shot off of like one air handler, but the rest of the air handlers are fine, okay, then go ahead and fix it. But if it's every single air handler that has the issue, no, you're better off doing what you need to do to keep the job rolling, get the program involved to go ahead and fix it and correct the program. Another thing would be, I mean, really, it's anything with the sequence. Like when I'm checking out a job, I'm going to take the sequence and I'm actually going to put it in a spreadsheet. And so I'm going to take the cooling section and I'm going to break that down, maybe a sentence, or two or three sentences. And then once I know I'm at that part of the sequence, I highlight a box saying that's checked out. This is checked out. And this is checked out, because guess what? Those kinds of that kind of documentation is actually needed for commissioning, especially if you're on a new construction site. If you're on a new construction site, there's more than likely going to be a commissioning agent. And for those of you who may not be aware, a commissioning agent is an owner representative to make sure that they're getting what they paid for and that everything is working as intended per the specifications and the scope of work. Now, I'm trying to get us a person in here who was a commission agent turned technician to maybe talk about more of that stuff, but that's going to be for another episode. Hint, hint. But we need to make sure that documentation is correct to give to the project manager so they can give that to the commission agent, because they're going to need to see that before they even step foot in the building to check anything out. I think that's what I want to talk about as far as programming goes. Let's see, where else can we go? How about retrofit projects? With retrofits, and what I mean by that is you have a job that is existing, and maybe you're doing a controls replacement. So one thing that may happen is you're given a set of mechanical drawings. You may find the original control drawings on the site. And, as a company who grabs that stuff and maybe does a site visit, they're going to put their own control drawings together for this new project. Or maybe we're actually adding on to a project. So maybe it's still part of a retrofit, but more of a renovation than a retrofit. Maybe we're adding a couple VAV boxes somewhere. Well, some of the challenges that you can see on retrofit solutions. One, the original control drawings that you were given from the original job were not actually the as-built, or maybe the as-builts are incorrect. So you could have some things that are wired not in the right terminals as you're ripping it out. So you may have to verify some way. Hopefully the controllers are still online and maybe you have access to the original programming. You can see how that stuff was set up. But if not, you're going to have to do a point-to-point to make sure that they are wired as intended, and if it's going to cause any issues, those could be change orders. Now, typically those kinds of things there's usually time in the job as part of the scope of work. Hey, there's X amount of time that's going to be charged to the job for a proper walkthrough, but not everything gets caught at the same time. So a lot of things I've seen, Matthew, I've seen that 10 VAV boxes that were not accounted for. There was one, I think it was 15 to 20. It was here in Charleston. We were actually replacing. Now, unfortunately, there was no DDC in the building ahead of time. It was all pneumatics. And so we ripped off all the pneumatics and put DDC controls on top. Well, it was a 5-story office building, and we found that there were like 15 or even more VAVs that we had there. And so, luckily we had enough controllers to do the job. But at that point, did we want to stop and, say, hey, Mr. Customer, we found these boxes that were not a part of the original schedule. We're not going to do anything with them until you pay us. Or do you go ahead and eat the cost right now and work it out with the customer? Like, hey, look, you guys had this. It was actually this. Maybe you don't charge them all. Maybe, say, hey, look, if you pay for half, we'll eat the other. We'll eat the other cost of that. That stuff can kind of happen as well. Maybe you have actuators that are supposed to be floating control, but you actually have found that they're modulating. They've all been replaced. So a lot of the DOs that you may have for that floating control aren't there anymore. Maybe they're all analog outputs, and maybe you had a controller that was designed to have more digital outputs than analog, and now you maybe need more analog outputs. And so now what do? Well, you've got to replace the controller to apply, to have the appropriate number of analog outputs instead. It's really important to have accurate drawings, though most of the time you're not going to get that. So what I really recommend is to do a proper walkthrough and make sure you have the original control drawings. Get them up front. If they don't have them, then at that point, unfortunately, that cost is going to go to the customer for your exploration, because now you're finding things out that they may or may not have. It's also important to get in front of the original front end system if there is a front end. Now, if it's pneumatics, well, there is no front end, right? That's the air compressor and that's the air compressor, and that's the panel with all the gauges for the pressures that you see. But if this is like, let's say, a Network 8000. Okay, well, if this is an old job, for Network 8000, you got GCMs and you've got microzones and PEMs and and micronet, either microflows or micronet VAVs. Point being is that with an old system like that, all right, maybe you have host 8000 as your front end. Maybe you have Signal as your front end. Well, either way, we can actually then go into those systems and take a look and get an accurate detail of what is actually in the field. In addition, you'll want to know what's communicating versus what isn't communicating. I find that quite often that you'll have controls companies that will, talk to, that will negotiate a job, but don't do the proper walkthrough. And so at that point, you have a bunch of devices that aren't communicating, but the customer either A, knows that and they're not going to tell you, or B, they didn't know it because they weren't paying attention to the old antiquated system that they had. They just kind of floated around. And so then at that point, what does the customer say? Well, it was communicating before you touched it. And now, because even though there's no way it wasn't communicating, and you could probably prove that with a shadow of a doubt, good luck trying to convince the customer that that was going to happen. The only way that that's going to happen is if the controller isn't even there anymore. I've seen that where someone's like, well, it was working before you left. I don't know how, because the damper was locked open and there's no controller in here. So how was it communicating? Solar power? Magic? Not sure. But some of those things you're able to convince the customer, but otherwise, if you're taking over an existing system and if you've not done the proper walkthrough, be prepared to eat a ton of cost. The more that you can do ahead of time, the better, especially if you're integrating stuff ahead of time. There was a scenario where someone was supposed to take over a carrier network. And so prior to actually going to the old front end to take a look at it, they just integrated the carrier network. And all of a sudden they found out that a bunch of controllers weren't communicating. And so once they found it out, they actually took the communication trunk off of that and tied it back to the old system. But those same controllers weren't communicating. Well, now the customer is having a hard time understanding whether or not they were communicating or whether or not we did something to make them not communicate. So without those kinds of without that kind of documentation, those jobs are doomed, and I mean doomed for failure. Successful retrofits come with a lot of preparation up front and a good system in place to handle those kinds of oopsies. Does that make sense? Should that is there anything else you can think of or any additional question you want to ask about that?
Not on that. I mean, it brings up a point about um, as somebody having to not being the decision maker, having to work within that scenario. Should they raise their voice? And then at the same time, obviously, you're not always going to hear back what you think is the right decision, and you know how you should just move forward. Like, just you got to keep doing the work if you're there to do the work, and not it's it's not on you at that point. At least you said something.
Right. And so, it's also part of the project manager's role, right? Like if you, if you're talking to the project manager, say, hey, Mr. Project Manager, we're like 10 boxes short. How do you want to handle that? And, they're like, what do you mean you're 10 boxes short? And, well, what do I mean is, we're 10 boxes short. This was what was here. And we found this entire section of the building that wasn't, that wasn't in the takeoff. How do you want to handle that? Okay, well, let me talk to the customer, right? And now the customer gets involved and to determine what we how they want to handle that. Was on a job site in October. Found out after I did a walkthrough, and took and actually kind of handed it off to the application engineer to make sure that I had my head wrapped around the project, and then they got their head wrapped around a project, and we both were on the same game plan. After I left, he called me, say, "Hey Charles, guess what? I found 4 extra panels in a locked portion of the building that none of us had access to, that the customer eventually told us about." So it's like, oh, well, we didn't even know those existed. We were trying to find those things, and we assumed that because one controllers were labeled that way, that those were the labels. No, fun fact, they weren't even the controllers that were labeled that we were even talking about. So those things happen even if you do a proper walkthrough. Some information just doesn't get relayed back, and so at that point, I think that I think we had enough controllers that we ordered, so we took some of the spares and just put them there without charging the customer on that. But those are things that could make or break you. So, which I guess leads to one of my final thoughts is a miscommunication between you and the customer. Um, that's a very difficult thing to navigate. And you have the old adage, Matthew. What have we heard? In when it comes to retail or customer service, what do we hear about the customer? They're what?
They're always right. But
Right.
I've worked in the service industry, and I obviously know that's not true.
Correct. But it's hard to tell them that they're wrong. Or maybe you misheard something. So when things like that happen, um, you know, you may go on site. Let's say you're the technician, Matthew, and you were told by the project manager, "Hey, you're going to be checking out this air handler, and you're doing this and this and this," but didn't mention something else. And now the customer comes and says to you, "Hey, what are you here for today?" And then, they say to you, or you say, "Oh, I'm testing out this and this and this." And they go, "Well, what about that section right there?" Well, the project manager didn't mention that to me. Well, I talked to the project manager and I discussed it that way. And so you may not actually go back to the project manager at that point and be like, "Well, all right, I guess I'll go and grab the extra material for it and whatever." So you start doing it, and you give your report to the project manager at the end of the day or at the end of the week, and then the project manager calls you like, "Hey, why did you do that section? I didn't mention that section." Well, the customer said that you two talked about it and assumed while I was there you were taking care of it. They're like, "No, we were going to go through a change order, and now you've done that work basically for free." And so now without the scope of work, the customer is not going to pay for that, right? So those kinds of things, when you have a clear direction of what you're supposed supposed to do on a job site, and the customer gives you something that directly contradicts what you're supposed to be there for, immediately talk to the project manager to make sure, like, hey boss, customer's saying this, is that correct? And then the project manager, like, oh yeah, we talked about that this morning. Sorry, I didn't mean to give you sorry, I didn't give you that information. Or no, that's not correct. Let me call to the customer and find out what's going on, and I'll call you back. I remember a scenario of when it came to running. I was dealing with a bunch of Ethernet level devices, and it was unclear whether or not the customer was supposed to run the cable or whether we were supposed to run the cable. Now, the scope of work said nothing about who was running the cable. And there was a he said, she said kind of scenario where supposedly the customer said, well, we asked you if we needed cables, and you said you could use the existing cables. And then I go to our side, and they're like, no, we never told them anything like that. Well, knowing some of the people that I used to work with, it was quite possible that they told them that they could use the existing wire. Like, I had enough experience with those people that told me, yes, you have told the customer incorrect stuff before. And I then kind of have to make a decision. And so, some of those things, like, well, I just, how do you go about that as a technician? Do you start running the cable? Do you get an installer to run the cable? No. You put those two parties back into a meeting, and you watch them duke it out. Do not take the onus on yourself to implement any of those changes, because there are people that will take advantage of that, and that is what I say below your pay grade. You have people that are made to be put in charge of those kinds of decisions, and that is not something that you need to stress yourself with. Even when it comes to graphics or anything like that. From a graphic perspective and a slight programming perspective, I do say there should be a few liberties in place. If it's going to take you an extra 10 minutes or, let's say a half hour of your time, and that's it. Like, this is it, what you need? Yeah. Okay. Are you really going to involve someone by the time you get a project manager involved and then they generate a change order? Well, that's 8 hours of time right there spent just doing what the 30 minutes of additional work could be. Yeah, I'm probably not going to get the PM on that. I'm just going to go ahead and take care of it myself. If I need an extra relay somewhere, and again, it takes, another, 20, 30 minutes, and I've got the excess wire right there. Okay. Might as well put it in there before I raise a big stink about it. Oh, this is going to take a half a day. Well, I had all this scheduled. So if I try to do this, that gets pushed back. I'm going to call the project manager. Hey, customer wants to do this. It's going to take about this amount of time. I know you had this set up. How do you want me to proceed? And they can say, you know what, just take care of it. This customer is a potential, this customer has potential to buy more for us. So if I think we help them out here, that might go a long way in our favor to getting some additional projects. Or no, this customer has been extremely difficult. Every match of the way, everything has been wrong. No, we're charging a change order. And I'm okay with either way. I'm not saying that one is right or wrong. Any additional work outside of the scope of work is indeed a change order. It's whether or not the company perspective feels that they actually need to charge for it. Sometimes we don't. Sometimes we do. It really can go. It can be dependent from customer to customer and job to job basis. So, really to kind of sum that up, understand your role in the hierarchy of where you are in the company, as far as like technician, installer, programmer, engineer, project manager, etc. And then once you have that role and that level of understanding, do not necessarily take liberties that could potentially cost the company serious money or harm. There's nothing wrong with taking the communication and respecting the chain of command. I will never disrespect anyone doing that. Like, hey, even if I'm the customer and I'm like, hey, can you do this? And I know how long it takes, because let's say I no longer, I'm not doing training anymore. I'm just going to become a maintenance engineer, and I'm going to maintain this building. Now, obviously, having the experience that I have, I could do a lot of the work myself, and I don't need ABC Controls Company. But that's not what I'm here for. I'm here to bring you on to do something. But let's say I know something isn't right necessarily. Okay, well, hey, Mr. Technician, I saw this here. I think it needs to be this. Can you fix it? And if they say, well, I need to talk to my project manager. Okay, all right, great. Thank you. Let me know. And then the project manager tells me, hey, we're going to take care of that for you. No problem, Charles. Okay, great. Thank you. Or, hey, well, the sequence actually called for this. And I know that may not necessarily be right, but in order to change it, we have to do it this way. Okay. All right. Well, give me the quote for the change, and I'll run up the flagpole. So a lot of that really needs to be taken with care. And again, not all of this is, mind you, a lot of things I'm saying right now aren't necessarily hard and fast. These are all just guidelines that I've learned from my own bad beats as well. I've made my fair share of mistakes at controls companies. The first company I worked for, I talked to the customer a lot, and there were things that I said yes or no to, and I shouldn't have, and it costs it caused a lot of grief. And so I learned from that point, well, yeah, all right, I'm not talking to the customer anymore. I'm going to let someone else handle that. Those are the main things I think are really important. Well, that's all we have for the episode today. Remember to stay curious and know who's running the cable. I'm Charles.
And I'm Matthew.
And this has been It's a Controls Problem. Those near and far wars.
Make your mark, dog.